This has been out for a few days now, and I'm extremely excited about covering this Mercury Coder. This is, I feel like, a paradigm shift. It is something brand new and it could really change AI coding for the future. This is the first commercial grade diffusion large language model. And we don't necessarily associate diffusion with text generation or code generation for that matter. We generally, when we think about diffusion models, it's generally for images or videos. And if you don't know what that means, this is what it looks like. So when you're generating an image using AI, first you will have this very grainy image, and over time it's going to clear itself up. And finally, you will have a very clear image. And same thing. So if you want to see something more clearer, look at this. This is how it will be. We'll have a very grainy image, and over time it will clear itself. And that's just what diffusion models are. And this technology that this Mercury Coder is using, it's the same thing, but nobody has really tried this diffusion model with text. Okay, and we'll go deep into this one. And this is by a new startup called Inception Labs, pioneering in new generation of large language models. And their pin post here says, "We are excited to introduce Mercury, the first commercial grade diffusion large language model, dLLM. dLLMs push the frontier of intelligence and speed with parallel coarse-to-fine text generation." So if you see this video here, you can see that this is significantly faster, right? So let it start again. So this is from Inception Labs, and write a function for LLM inference. And you can see iteration 3, 4, iteration 9, 10, and 14. It's completed. And here it's starting from left to right, and it's taking 75 iterations to complete it. So this is significantly faster, which means that it is going to be significantly cheaper for us as well. So this is how it is. It will generate the whole text in one go. It might not make much sense initially. It's like the grainy image, but then slowly it will refine itself, and we can see that it's significantly faster to do this way. And you'd get a better understanding if you check this out. If you see here, okay, write a detailed guide to object-oriented. So same prompt was given to Mercury, ChatGPT, and Claude. See how much faster Mercury finishes. It finishes in 6 seconds. And ChatGPT and Claude is just keeping on going. They're still going. So Claude took 28 seconds to finish it, and this one, ChatGPT, took 36 seconds. That's where I feel this is groundbreaking, because I've been coding with 3.7 Sonnet, and as amazing as 3.7 Sonnet has been, it's been writing codes, like really large codes, in one go. But it's taking such a long to write that. So sometimes I'm like, waiting there for 10 minutes, doing nothing. It's writing the code. And sometimes when a button shows up in cursor, I'm just clicking on that button and then letting it do its stuff. And I'm just waiting there for things to happen. So I'm not able to see much. But like I said, the quality of the code has been amazing in Claude 3.5 Sonnet. This is obviously not on that level when it comes to the quality of the code, because this is the first of its kind, and it will grow. And I'm sure if this technology develops for us users, this is going to be amazing. Like, we are going to be able to pay much lesser and get the results much faster. And we'll be able to develop apps and websites very, very fast. So if we just go to their website, you can see introducing a new generation of language models. And this is just how the generation happens. You saw that, look at this. This is how the text generation is happening. Initially, there is a lot of jumbled up text, which doesn't make any sense, but then it will combine together and make something meaningful out of it later on. Let's actually check the coder first and then go do some more digging. So here we have some suggested codes. I'm just going to click on this one. So here the interface looks more or less like every other one, except for this button here, which is, I'll on it for the next code. Let's do one thing. Let's actually click on this one, create a Pong game. And I'm just going to let it run and see how fast it is. Boom, it's done. Okay. And that is amazing. And if you see here, I'll just go to full screen, and this is the output that we've gotten. Okay. And it was so fast, right? Let's create something else. And this time around, I'm going to toggle this diffusion effect so that we can see how this diffusion actually works. And that's why I've actually selected the dark mode so that we can actually visualize it very clearly. In the light mode, you cannot really see it so fast that you cannot actually see what is actually going on. And let's do one thing. Let's select this one. Okay. Create a JavaScript animation. I'm going to click enter and see here. You can see, okay, yeah, it's so fast. It's created all those text and boom, done. It's already done. I'm going to click on full screen and this is what we have. This is what the coder has created for us. Okay. So let's give it some custom prompts and see how it performs. So I'm going to actually select this prompt from here. These are prompts that I've used earlier in my other videos. I'm going to just let it run and see how it's so fast. It's so fast and it's amazing. All right. So let's open it in full screen. So straight away, I can see that it has not taken into account the part of the prompt where I mentioned I don't want any card-like designs. It's actually a card-like design. So anyway, let's see if it works at all. Let's add task. We can change the name. Okay. So that works. I can delete it. So this part has worked with every single model. So that was never a big worry. This is the portion that needs to be checked up. So let's click on that. Okay, the name is not being added. Let's add one more. And this is the thing. Will it move it up? I'm not sure if it is doing it because they're all the same. I'm going to assume it is not. Okay, so this is the output from that. So let's see the other prompt and see what we get. So let's go back, create new, and let's see what we get. Okay. So this is actually amazing to see. Look at that. Like this is not how coding works with AI, right? And let's go to full screen. We can see the images icons are missing. Let's add a new one. Okay. So it's not as pretty as the other models. It is flipping. That's okay. Okay. The left side is not flipping. The right side is flipping, which is, oh, I think these are the first one, which was already there. So not as great, but having said that, this is, if this model does really, really well and has significant growth, we will end up paying significantly lesser for AI coding. And that is something that we can always cheer for. And I'm sure it will get better with time because this is literally the first public iteration of this model. And if you just dig a little bit deeper, I'll just go to the blog post. And if you see here, introducing Mercury, the first commercial scale diffusion large language model, we trained the diffusion large language model that are up to 10x faster and cheaper than the current LLMs, pushing the frontier of intelligence and speed for language models. Okay, so let's go down and you can see how much faster this is. So look at all these things together and Mercury is significantly faster here. And if you read this section, a dLLM is a drop-in replacement for a typical auto-regressive LLM, which is generally what we have, which will start from left to right, and that's how it writes the text. This one generates all together, including RAG, tool use, and agentic workflows. When prompted with query, instead of producing answer one token at a time, the answer is generated in a coarse to fine way, as illustrated in the above animation. Improvements are suggested by a neural network, in our case, a transformer model, which is trained on large amounts of data to globally improve the quality of answer by modifying multiple tokens in parallel. So this is the exciting part for us. What next with this model? So Mercury Coder is the first in a series of upcoming dLLMs. A model designed for chat applications is in closed beta. So this will unlock new set of capabilities like improved agent. dLLM speed and efficiency make them ideal for agentic applications that require extensive planning and lengthy generation, advanced reasoning, controllable generation. dLLM can edit their output and generate tokens in any order, allowing users to inhale text, align output with objectives like safety, or produce outputs that reliably conform to user-specific formats. Fourth one is edge applications. Given their efficiency, dLLM excel in resource constrained environments such as edge deployments on phones and laptops. So clearly, this is a very, very exciting and fascinating development in the AI field. And I'm super excited to see where this goes forward. And this is what we have right now. So that's it for this video. If you'd like to watch more videos like this, please subscribe to the channel, like this video, share it with your friends, and I'll see you in the next one.